All right, lesson 4 is introducing a brand new way to do ratios called TRF. Everybody say TRF.
TRF.
Good. It stands for template ratio find. You've kind of been doing it already when you did the rainbows to find missing values in a ratio or a pair of equivalent ratios. It's very similar to that. It just formalizes it a little bit more in labeling what's what. So that being said, I'd like you to flip to, I guess, page 2, please. Towards the middle of the page, where it's warm-up whole class, I want to reintroduce to you the idea of what a constant is. If I have a pair of equivalent ratios like I have here, 1 to 3 is equivalent to 4 to 12, we have been able to make a connection between the two ratios using a multiplicative constant. So when you go from here to here, you're multiplying by 4. Same thing here. Everybody see that? One other way that you can find missing ratios or missing values in a ratio is looking from the top part of the ratio to the bottom and seeing if there is a multiplicative value that can be used for that. Does everybody see here that 1 times 3 will give you 3?
Yes.
That's called multiplicative structure. Can you say it?
Multiplicative structure.
You can use either constant or multiplicative structure to figure out missing values in an equivalent ratio. Both strategies can be used, and you will see sometimes it will work both ways. So that being said, let's take a look at number 1 in part 1. We have a missing value. First thing I want to do is, can we make a connection using a constant between 2 and 8? And if so, what is that value? Z.
10, that constant's 4.
Correct. Okay? Whatever you do to the top part of the ratio, you must do to the bottom. So once you have that constant of 4, you can now do your 5 times 4 and get what?
20.
20. Missing value is 20, and we used a constant of 4 to do that. All good?
Yes.
All right. The other thing to point out is that when you look at multiplicative structure, 2 to 5, there is not a whole number that can be multiplied by 2 to give us 5. It winds up being a mixed number or a decimal of 2.5. So you have to look at both. There's always going to be an easier way to try to figure it out. And in this case, constant is a better method than multiplicative structure. Okay? Let's go to 2. Page 3, number 2. Always try constant first. Can you make a connection? Is there a number that could be multiplied by 3, a whole number that could be multiplied by 3 to give you 4? Yes or no?
No.
So now look and see if you can make a connection in multiplicative structure. What about 3 and 9? And if so, what's that value to multiply by?
3.
You got it. Once you have that, that multiplicative structure will work for the second ratio. 4 times 3, everybody say it out loud.
12.
You got it. In this case, you use multiplicative structure. We kind of did we do this? We did a little bit of this yesterday when we were doing the review game for the quiz, right? Did we do that? Did we get to that? I don't think we got to it. I think period 3 got to it. Okay. So we did not do 4 corners yesterday when we did the review game. Okay, so period 3 did. I kind of gave them a little bit of a head start. I give you a missing number. Here, it's this. Did we do this where I gave you a missing number? That's what it is. That's exactly what it is. The only thing that was different there is I did not allow you to use multiplicative structure because I didn't teach it to you yet. All right, so this particular exercise, I call it 4 corners exercise, and it appears a lot in review sheets throughout the year. Some of you will get it right away, and some of you will struggle through it. especially when the missing values are on the first part of the ratio. Okay, so let's take a look at number 1. Take the values that we do have 2 of in a constant. Well, you have a missing value here, but you've got 2 values here. So will it work? Is there a number times 7 that will make 21? Cody.
3.
Okay, so we have a constant of 3. Once you get it, it will work for the top. But you got to kind of think backwards here. What times 3 gives you 6? You don't want to do 6 times 3 and make this 18. You don't want to go backwards. You still got to go forwards. Or you can do, if you want, 6 divided by 3. If you go towards the left, just divide. John, you got it. Missing values 2. Some of you will see it right away, and some of you will have some difficulties with this. All right, number 2. Well, I'll call on you. Go get me an animal.
Ooh, bunny.
Your choice.
Look for bunny. Why does it videotape it?
It's not going to videotape the animal. Nothing's getting videotaped. It's just our voices and the smartboard. So, but it can hear you. Ah, you picked a good
Hi,
one.
Mom.
Okay. So if I call on you, I tell you what. Let's do it this way. I'm going to call on you and tell me what the missing number is, and then I'm going to ask you what you used: multiplicative structure or constant. Missing value first.
Got 10.
Okay, you got 10. Everybody agree 10?
Yes.
What did you use, constant or multiplicative structure? Constant is what? Could you also use multiplicative structure?
Yes.
Sometimes it will work both ways. Either or. In this case, you could have gone either direction, and it will always work both ways. It will. It's just that one way normally is easier than another. All right, what about number 3? Ben. Correct. What did you use, constant or multiplicative structure? And what is that constant, Ben? Good. All right, number 4. Oh! What do you got for the missing number? Okay, 56. What'd you use? Of? Will multiplicative structure work also? What's the multiplicative structure value? Times what? Say it. Yup, you can also go this way. It does work out evenly. And it's also a good way to check and make sure that your constant works. Yeah. Somebody call my name?
Oh, that's John.
Go ahead.
You can do 8 over 7 like that, right? In the corners.
Which one?
2 times 7. And then you get 56.
Yeah, 7 times 8. I did it that way. Same idea. Back on.
Oh.
So you kind of understand how you can use both multiplicative structure and constant to find missing values, correct? Yes? It takes some practice, and they do kind of get harder throughout the year because there will be times where none of either the multiplicative structure or the constant will work out evenly, and you still have to find that value. That being said, we're going to use that strategy, multiplicative structure or constant, to solve word problems using what's called TRF, or template ratio finds. First thing I need to do is introduce you to a new word called rate. Rate is very similar to ratio. The only difference is that you're comparing things that have different measurements. Like if you drive in the car and you're driving 55 miles per hour, what's the ratio? Think about it, because it's a rate or a ratio, 55 miles per hour. What's the ratio?
55 to 1.
Right, it's 55 miles per 1 hour. That's a ratio. It's 55 per 1 hour, 55 to 1. That's what we mean by a rate. You're comparing miles to hours. That's what a rate is. That being said, let's take a look at the first word problem. And what I want you guys to get into the habit of doing is circle your given ratio and underline what you're trying to find and what else they give you. I'll take you through the process. All right, let's take a look at this first question. David can clean pools at a rate of 3 to 5 pools per hour. How many pools can David clean in 10 hours? What's my given rate, my given ratio or given rate? Luke.
3 to 5
And comparing what? 3 to 5 what?
pools per hour.
You got it. Circle that. That's my given rate. We're going to need that when we put this into the template. What are they asking us to find? How many pools or how many hours? Read the second part of the question. Viv. I'm going to need it. I need to know what they're asking me to find. And part of that sentence, what else are they giving us? Because we're going to need that value. It's an important number.
How many pools will you clean?
10 hours is my second piece of information that I need. I now have everything I need to figure out how many pools it will take for 10 hours. The steps here are outlined to kind of remind you what to do, but it's kind of really basic. The first thing that you do is you make what's called the template, the labels. What are we comparing? What to what? Where's the frog at? Okay. Andrew, what am I comparing? What am I value? What am I comparing? What are my quantities? Or what are my labels?
Okay.
Not numbers. What things are we comparing?
How many pools can David clean in 10 hours?
Okay, so pools over hours is my template. Fill that out. And for right now, spell everything out, but eventually when you get the hang of it, I will allow you to abbreviate that as long as it doesn't start with the same letter. Step 2, what is the given rate? What rate do they give to you in the first part of the word problem? Toss it to a girl. Nicely. Ah, who's that for? Three to 5 is my ratio, okay? We're gonna put it into the ratio exactly the way it shows in the word problem. What are they asking you to find? Look back. Toss it to a boy. I can't hear you. What?
What was the first?
What are they asking you to find?
Oh, they're asking you to find,
What did you underline in the second part or the first part of the second sentence?
two things I can put.
No. Look back at the word problem because we're circling and underlining things in that word problem for a reason. Toss it to anybody. What are we trying? Stop right there. How many pools is what you're trying to find? Make a box for pools. Notice, my box is at the top for what reason? Tyler. Okay, but why do I put pools at the top and not at the bottom? Why is my empty value or my box at the top and not the bottom?
Because in our given rate, on the top is the pools.
Yes, that's the reason why we make a template. Everything having to do with pools has to go on the top, and everything having to do with hours must go on the bottom. Finally, what is the last piece of information that they give to you in the word problem that I can now put in the find part of the template? 10 hours. Whenever you have 3 out of the 4 values, you can now use either constant or multiplicative structure to find the missing value. What do you want to use? And what's the missing number? Phil,
Constant, and missing number is 6.
you got it. See, we can make a connection between 5 and 10. Constant is 2. Whatever you do on the bottom, you got to do on the top. Use that constant to fill in your missing value, and now all you need to do is state it in a complete sentence. He can clean 6 pools in 10 hours. And we're just going to practice it today and Wednesday when we come back. Can I flip? Okay, do me a favor, read example 2 quietly to yourself, and then I'm going to ask you some questions. All right, the first question is, what should I circle? Joe.
39.
And I do want to include also the label pages per minute, because I'm going to need that in the template as well. What are they asking us to find? Look for keywords. How much, how little, how many. That gives you the indication of what we're trying to find. John, I'm going to you.
Minutes.
I'm going to underline that. And then finally, give me the second part. What are they giving us in the second part of the sentence?
The second pages.
And I'm going to underline that. Got everything I now need to plug everything in where it needs to go. All right, I'll take the frog back. What's the template? What over what? What are my labels? I keep forgetting your name, so give it to me again. No, give me your name again. What's your name? Geneva. I'm sorry, Geneva. I'm almost there. What's my template, Geneva? Sounds good to me. All right, stay with it. What's my given ratio? Geneva, still you. Good. What are we trying to find? How many minutes is my empty box? Minutes is on the bottom because my template establishes everything having to do with minutes has to go on the bottom. And then what do they give us for pages? Still, finish it up. Might as well.
3.
No. 3 is given in the given ratio.
7.
Yes, 7. Okay. Somebody else, tell us what we want to use here, constant or multiplicative structure. Kurt.
Multiplicative structure.
Correct. See, I can't tell from here to here. It doesn't go evenly. But I can use this. This goes nice and evenly. Multiplicative structure of
3.
times 3. Therefore, Kurt, what's our missing value for minutes? Very good. Yes? Good? It's easier than making tape diagrams, isn't it? All right, you can do it using tape diagrams. It can be done, but the kids over the last 3 years now that we've been doing Common Core like this method the best. It doesn't mean you have to use it. Some of you will still want to use tape diagrams, and that's okay. But some of you are ready for this because it's just a little quicker and it just connects with you a little more than tape diagrams do. See, Common Core is all about exposing you to as many different strategies as possible. In the end, you pick what works best for you. Okay? Over the years, kids have used TRF the most, but not everybody has. Some still use tape diagrams, and some still use equivalency ratio tables. All we're doing is exposing you to as many different strategies as possible. And there'll be a couple more along the way, too, that you may like. But if and you get it, and you can connect, and use it. It's a tool. It's a resource. Finally, we just got to put it in a complete sentence. You're just answering the question. How many minutes will it take? it will take 21 minutes. Try example 3 all on your own. I'm going to walk around. All right, Cody, you're now live. Do you need to go back and get your stuff? If you do, let me unstrap you and then come back so you can look at your notes. All right, go. Come back up. This one is a little tricky in that they ask you whether, based on whether you can do this in 55 seconds or not. All right, first thing, Cody, I want you just to fill out your template and your ratio.
So I did, wait, no, seconds to meters.
Good. And once again, that can usually be found in the very first sentence. What are the templates or the labels of the things you're comparing? Now the given ratio.
I did 3 to 5.
Yes.
And then I knew that he had to swim 100 meters, so.
Yep, put that in and stop right there because I want to show everybody that. We don't know whether he's done this in 55 seconds or not, but we do know he needs to swim 100 meters. We're trying to figure out if he can do it in 55 seconds or less. So from this point now, using either multiplicative structure or constant, find the missing value.
So I knew that 5 times 5 multiplied by something would be like times 20.
Mm-hmm.
Then I knew I had to do times 20 for this, which gave me 60.
Step out so everybody can see that. So if you do this straight up, 3 to 5 is an equivalent ratio for 60 to 100. So now you got to go back and say, okay, if he was actually swimming this at the rate of 3 seconds per 5 meters, it would take him, everybody, how long will it take him to do 100 meters? Just say it.
60 seconds.
Will he qualify?
No.
No, it's too slow. He's got to do it in 55 seconds or less. So the answer is, and you're going to write it on a sentence, no, he will not qualify. Finish it up, Cody.
All right. He will not qualify because he is 5 seconds late.
That's exactly the way you want to write it. It's 5 seconds too slow. He's got to speed up the pace. Here, let me extend it for you so you're not blocked by your shadow. There.
Qualify.
It's
I
okay.
don't know.
Good. Finish it up. You got the right idea. It's all right. You got it. Give him a round of applause. You did a good job. All right, try your last example for today, and then you guys will be ready to rock and roll with the exercises for Wednesday. One more example. And again, I'll walk around.